In order to solve this, we need a whole brand new kind of number. This brand new kind of number is called the imaginary number. This imaginary number is I. That is the definition of the imaginary number. That's all the imaginary number I is. It's the square root of -1. That's all. By definition. So they said, let's imagine this number is, this I is the square root of -1, then what would its properties be? Now we can do this kind of problem. Property of multiplication says -81 is equal to 81 times -1. Would you agree with that? And the properties of square roots say that I can divide that into two separate square roots. And what is the square root of 81? And by definition, up there at the top of your page, what's this equal to? Now, we can solve out that kind of problem because we have this special number. The property of multiplication tells me that -4 is the same thing as 4 times -1. The properties of square roots say I can divide that into two separate square roots. The square root of 4 is 2. By definition, the square root of -1 is this new important special number called I, the imaginary number. It is I. You thought I was a letter, but it really represents a number. The number it represents is the square root of -1. This would be equal to the square root of 49 times the square root of 1. What's the square root of 49 equal to? And this is I. Now, as I mentioned just a minute ago, often this number is used in particular to do electricity kind of problems. And when you do electricity kind of problems, your numbers have a real number part and an imaginary number part. If you put both of those together, that is called a complex number. A complex number has a real part and it also has an imaginary part. And you can't combine these and make it into a 13i because this new number has to follow all the same rules that you've already learned in your arithmetic and algebra. And one of the most important rules you've learned is combine like terms. You can't combine these because it's not alike. The 7 is the real part because it doesn't have an I. And the 6 is the imaginary part because it does. The 3 is the real part and the 5 is the -5 is the imaginary part. This doesn't have an I. This does. Do you see where this goes on your paper? 2 is the real part. I is the imaginary part. And these special new numbers follow all the arithmetic and algebra rules that you've already learned. This next problem is not on your paper. Just look right up here. This shouldn't be a difficult problem to solve. One girl in my other class period got concerned about the parentheses. When you're adding problems, adding polynomials, the parentheses don't really have any use whatsoever, and so I can just get rid of them. This is all on the same order of operation. That was just to group them. And then you do what? Combine like terms. What's going to combine with the 5? And what's going to combine there? And that's going to give you a -3x. Is that easy? Okay, over here, when you're just adding, the parentheses really don't have any effect. What am I going to combine with the -4? And so that would be -12. Would you please look at problem A on the next page? What do you notice about this problem right here and problem A on your next problem? It's the same. It's the same problem, except your problem has an I. So the only difference, if this has an I, it's going to work the same way. You're going to combine like terms, and that is the answer for part A. If you have a real number and imaginary part, you just combine the like parts. This is exactly the same as your problem B, only problem B has an I. It works exactly the same, except it has an I instead of an X. All you do is combine like terms for addition. If you have subtraction, the only difference is you have to distribute the negative sign. So this would be a -6, a minus would make a positive 10i. Distribute the negative and then combine like terms, if it's a subtraction problem. If it's an addition problem, you just combine like terms. Those are alike. And when you write a complex number, you write the real number first and the imaginary, the I part at the end. That's just traditionally the correct way to write it down. So the real number part comes first and the imaginary part comes second. All you do is what you've already learned. Combine like terms. If you have a subtraction problem, you have to distribute the negative and then combine like terms. This would make a positive 1. This would make a negative 4i. If you have a subtraction problem, you distribute the negative and then you combine like terms. What happens when I combine those two like terms? A -3 and a +3 cancel each other out. So then I have these combined terms, and so the answer is 13i. To add, you simply combine like terms. To subtract, you distribute the negative and then combine like terms. Worksheet 4-5 will be due on Wednesday, but it shouldn't take you nearly that long to get it done.